For almost 50 years, Voyager 1 has been moving farther than any human-made object ever has. Silently, it slipped beyond the sun's influence and into a region once believed to be nearly empty. Built in the 1970s and engineered for a mission lasting only a few years, this fragile spacecraft is still communicating with Earth after more than 45 years in space. And what it's telling scientists now is deeply unsettling. Voyager 1 has reached a boundary no probe was ever intended to study directly, and the data returning does not fully align with our models, our predictions, or our expectations. Tonight, we're going to uncover what Voyager 1 discovered, why scientists describe it as impossible, and how this single spacecraft is forcing us to rethink what interstellar space truly is. Voyager 1 is a machine that should have gone silent decades ago. It was created in an era when computers were primitive, memory was measured in kilobytes, and data was stored on magnetic tape. NASA never imagined this probe would still be functioning 45 years later, much less sending back observations that challenge modern physics. Voyager 1 was launched during a once-in-176 years planetary alignment that allowed it to steal momentum from the giant planets, skipping across gravitational fields like stones across invisible hands. That celestial choreography carried it past Jupiter and Saturn, revealing volcanoes on Io, fractured ice on Europa, and a solar system far more dynamic than expected. When its primary mission ended, Voyager 1 didn't slow down. It didn't stop, and it didn't fade into silence. Instead, it kept traveling outward, farther than anything humanity had ever built. Quietly, it transformed from a planetary explorer into something far more significant, the first true interstellar scout. For decades, scientists debated where the solar system truly ends. The heliosphere, a vast bubble inflated by the solar wind, was expected to form a clear boundary between the sun's influence and interstellar space. Models predicted a sharp transition, like crossing from calm waters into a different ocean. Voyager 1 was supposed to detect a dramatic change in magnetic field direction the moment it crossed that line. Instead, something deeply confusing occurred. As Voyager 1 approached the helipause, plasma density surged nearly 80 times higher than before, a clear sign it had entered a new region. But the magnetic field refused to behave as predicted. Its direction remained strangely aligned with the sun's field, even though theory demanded a sharp twist. This wasn't a minor error. It meant the boundary between our solar system and the galaxy wasn't a clean edge, but something layered, tangled, and far more complex than anything drawn on paper. This was Voyager 1's so-called impossible discovery. The data suggested the helipause behaves less like a wall and more like a turbulent shoreline, where solar and interstellar forces blend instead of separating cleanly. Magnetic fields fold together. Charged particles swirl unpredictably. Rather than stepping into a new environment all at once, Voyager 1 drifted through overlapping regions where solar influence lingered even as interstellar plasma dominated. This directly contradicted decades of theory. Scientists were forced to accept an uncomfortable truth. They had misunderstood the shape and behavior of the solar system's protective bubble. Voyager 1 wasn't confirming predictions. It was rewriting them. The boundary of our cosmic home is not static, symmetrical, or stable. It is dynamic, alive, and shaped by chaotic forces. And the consequences extend far beyond theory. If the heliosphere is porous and turbulent, then our solar system is far more exposed to galactic radiation than previously believed. Voyager 1 showed that cosmic rays penetrate deeper and interact more intensely with solar particles than expected. This matters because the heliosphere is the shield protecting every planet, every spacecraft, and every form of life on Earth from the galaxy's full violence. Voyager 1's data suggests that this shield breathes, shifts, and weakens under conditions we're only beginning to understand. The implications ripple outward, affecting long-term space travel, radiation exposure, and even how common life might be elsewhere in the galaxy. Voyager 1 didn't just uncover something unexpected. It revealed how little we truly understood the space we thought we knew best. What unsettled scientists most wasn't just that Voyager 1 entered interstellar space, but that it did so in a way no model accurately predicted. For years, simulations depicted the heliosphere as a smooth, balloon-like structure expanding and contracting with the solar cycle. The helipause was expected to shift significantly as solar activity changed. Yet Voyager 1 crossed the boundary at nearly the same distance Voyager 2 would measure years later, despite vastly different solar conditions. This shattered the idea of a simple rhythmic system. Instead, Voyager 1 exposed a structure where large-scale stability masks intense small-scale chaos, forcing physicists to admit their understanding of stellar interactions with the galaxy was incomplete. Scientists now describe the helipause as a shoreline. Instead of a rigid wall, it's a coast where two oceans collide. Solar particles push outward. Interstellar matter presses inward. The result is turbulence, mixing, and constant motion. Voyager 1 detected twisted magnetic fields, fluctuating particle densities, and irregular structures resembling waves crashing and retreating. The sun doesn't carve a clean bubble in the galaxy. It negotiates continuously. The boundary shifts, folds, and forms pockets where solar and interstellar influences coexist. Voyager 1 wasn't crossing a border. It was navigating a stormy transition zone no one had ever directly measured. As Voyager 1 traveled farther beyond the helipause, another troubling pattern emerged. Galactic cosmic rays increased dramatically, confirming that interstellar space is saturated with high-energy particles capable of damaging electronics and biological tissue. Inside the heliosphere, these particles are partially deflected. Outside, there is no protection. Voyager 1 revealed that this radiation environment isn't occasional, it's constant. This suggests the galaxy is far more hostile than once assumed, and that planetary systems depend heavily on stellar bubbles for long-term stability. In other words, life-friendly environments may be rare not because planets are uncommon, but because effective cosmic shielding might be. Perhaps the most remarkable part of this story is that Voyager 1 is still teaching us anything at all. Built with technology millions of times weaker than modern systems, operating on dwindling power and slowly shutting down instruments to survive, the probe continues delivering discoveries that reshape astrophysics. Many scientists studying Voyager 1's data today are younger than the spacecraft itself. Voyager 1 has become a living time capsule, bridging generations and forcing each new wave of researchers to confront the same truth. We do not fully understand the space beyond our solar system. And the farther Voyager 1 travels, the greater that uncertainty grows. One of the most unexpected revelations is that the heliosphere is not a neat, symmetrical bubble. Instead, it's distorted and uneven, shaped by the sun's motion through the Milky Way. Voyager 1 showed that our solar system is plowing through interstellar material, creating pressure on one side and turbulence on the other. This explains why the boundary remains surprisingly consistent in distance despite changing solar activity. The heliosphere isn't breathing in and out. It's being sculpted externally, like a ship's bow cutting through cosmic waters. Our solar system isn't isolated or stationary. It's moving through a dynamic galactic environment that continuously reshapes its outer limits. Magnetic fields added another puzzle. Theory predicted that once Voyager 1 crossed into interstellar space, magnetic fields should shift direction entirely. They didn't. Instead, the fields remained oddly aligned with solar lines. This forced scientists to reconsider how magnetic domains interact. Rather than snapping apart, they bend, drape, and merge across enormous distances. Voyager 1 revealed a universe where boundaries overlap instead of separating cleanly. Its instruments also showed that interstellar space isn't static. Plasma densities fluctuate. Particle flows shift. Magnetic turbulence varies over time. The space between stars is not uniform. It's alive with motion shaped by ancient supernovae, stellar winds, and shock waves traveling for millions of years. Voyager 1 isn't sampling emptiness. It's reading the fossil record of cosmic history still in motion. The most humbling lesson is that none of this was expected. Every major discovery forced scientists to revise assumptions held for decades. Voyager 1 didn't break physics. It exposed how incomplete our understanding truly was. Even the termination shock, the region where the solar wind was expected to slow dramatically, failed to behave as predicted. Instead of a clear, violent transition, Voyager 1 experienced irregular, delayed changes mixed with sudden spikes. The solar wind doesn't crash into interstellar space. It bleeds into it. Voyager 1 reached a region theory said should be obvious and loud. Reality was subtle, fragmented, and confusing. The probe also hinted that the interstellar environment around our solar system may be shaped by ancient supernova explosions. Voyager 1 is traveling through the fossil remains of cosmic catastrophes that occurred long before Earth formed. Space beyond a heliosphere isn't just hostile, it's scarred. Another unexpected pattern emerged. Chaos and stability coexist. On small scales, everything is turbulent. On large scales, the structure remains consistent. Voyager 1 revealed how order emerges from disorder across astronomical distances. Ironically, Voyager 1 is now making discoveries it was never designed to make. Its instruments were built to study planets, not interstellar space. Yet, decades later, it has become our most valuable source of direct data beyond the heliosphere. This proves that exploration doesn't require perfect tools, only persistence and a willingness to listen when reality defies expectations. As Voyager 1 ventured farther, distance itself became a force. Signals weakened into whispers. Control faded into prediction and trust. Beyond a certain point, command becomes an illusion. Voyager 1 operates largely on its own, following instructions sent long ago. Interstellar space challenges more than physics. It challenges the idea of control. Even noise became an obstacle. Space isn't silent. It's filled with electromagnetic interference from stars and distant energetic events. Voyager 1's faint signal must fight through that storm to be heard. The universe isn't empty or waiting. It's loud, crowded, and indifferent. After 45 years, Voyager 1 is no longer just an explorer. It's an aging machine surviving far beyond its design. And that endurance itself has become data, teaching scientists how systems fail slowly, how resilience emerges from simplicity. Crossing the helipause wasn't an ending. It was a beginning. Voyager 1 didn't leave the solar system and enter nothingness. It entered another domain entirely, one shaped by ancient stellar events and ongoing galactic processes. When you step back, Voyager 1's discovery stops feeling technical and starts feeling existential. The edge of our solar system isn't a line. It's a turbulent region where forces collide and reshape everything that passes through. What feels impossible isn't that physics broke, but that our assumptions did. And right now, Voyager 1 is still out there, drifting deeper into the unknown, quietly rewriting what we thought we knew about the edge of our cosmic home. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.